So welcome everyone to our final town hall of the year 2023. At least here at Naturalis today, we're in Christmas vibes because it's end of the year. And we're starting to celebrate all of the achievements that we've done, but also looking ahead. What do we want to achieve together in 2024? So thanks for showing up today. The recording will be shared through YouTube for those that cannot make it today. And please share, right? This is an open town hall for anyone interested in Arise, something that we cannot do alone. So please, by all means, help us also build the community around Arise and what's necessary around biodiversity. So just a quick reminder of the why and what we're going to do today. We're going to give you a general update. And in this case, we've prepared something very unique because we're getting close to end-to-end solutions, but the team leads will tell you more about this. So short presentations from sample to DNA barcode identification and also from sensor to AI identification, both streams of Arise basically coming together. We should finish at least within the hour, hopefully a bit sooner, and then we will start the breakout sessions because this is actually the most important part for us. Your feedback, your thoughts, your contributions to what you feel Arise should be about. So Arise, like I said, there's two big streams. One, can we recognize all species based on their DNA? Because it's a quick and scalable method to have indications of the state of biodiversity throughout the nation, but also something that can be applicable on a much larger scale, so Europe-wide or worldwide even. On the other hand, we have a lot going on around sensors. Can we automate some of the observations next to all of the manual work done by ecologists, of course, but can we put machines in the field that work 24/7, capture biodiversity information for us to complement all the good work and necessary work done by biologists? All of that, of course, comes together. So there's a lot of digital services around Arise, things you cannot really see or touch, but they're extremely important to get all of that data together and have it talk to each other. Make sure that the AI, for instance, helps us in identification. The data management helps us to connect DNA data with sensor data, have a user-friendly environment where you all can actually access your data, but also in a safe way and shareable way. So that ultimately all of that is connected and we can deliver on this big dream of having a reference database that captures everything around the species. Do we have the specimen? Do we know the taxonomy, images, DNA, sound, observations, and more? But it starts with, facilitating all of these pipelines, both in the lab, in the field, on the digital side, and making sure that that is all interconnected. So quick reminder of the 5 teams that are at play at Arise. They're cross organizations. So you see Naturalis, Westerdijk, the University of Amsterdam, the University of Twente, working hand in hand on a daily basis on this. These are the people responsible per team. Some of them will speak today, and by all means, reach out to us if you have any further questions. A quick recap of what's happening and what has happened. Please save the date for Arise Day, 27th of March. Everyone's welcome. We only have 200 spots. This is not an online meeting. This is our once per year in-person meeting, sharing information, sharing the vibe, sharing interesting knowledge and sites into information, also going beyond biodiversity. So if you have a chance, please join us. And then I'm going to hand over to Lotte, who's going to talk about the sequence.
I hope I managed to unmute. Yes, I did. Yeah, hi, I'm Lotte. Yeah. Yeah. Okay.
Eileen, please mute everyone and then the speaker can unmute herself.
What I'm doing. Ja, nu is het gedaan, maar was scherm.
Ja, gaat het goed? Oké. Okay, hi. I'm Lotte. I'm a team lead of the sampling team. And today, together with team sequencing, we will show you the entire end-to-end use case for creating a national DNA species reference database. So from sample to a DNA barcode. Yeah, in the next slide, you see all the steps that we take. And we will look at all the different stages. So from collecting specimens to publishing the results of the DNA barcodes. So let's start with collecting. Yeah, so before you can collect for us, you need to know what to collect. We closely collaborate with species organizations and individual experts, and they can use our online target list to see what we are still looking for. Which specimens do we have DNA barcodes from and which we don't have yet barcodes from. So you can search on any taxonomic level in that. So I made an example in the next slide, just to give an idea how that works. So here I searched for a genus. It's a bit small, I hope you can read it, but it's on the top right. You see that I searched for Scaptella, I believe you pronounce it like that. It's a genus. And then this gives me a table with results. And in this table, I can select which level, which taxonomic level I want to see. So if I select species, which I did, then I get a list of all the species that belong to this genus. And then in the right, in the table, the column that's called Arise, you see if we have already barcodes for the species or not. So in this case, one species we do have barcode from, and the other ones we still need. And there's also two other columns, all and all percentage. And that's all the barcodes from countries outside of the Netherlands that we might also use. So you can do this for any taxonomic level, create your own lists, and you can also export them then to Excel. That's sometimes easy to compare, for instance, with lists that you have yourself from species of a certain area. And we can also help with that if that's necessary. So it's no problem. So yeah, now you know what to collect. You can actually start collecting for us. Last October, we started with our sampling kits. These kits contain everything you need for sampling, for collecting for us. So manual, tubes, and material transfer agreements. And now, yeah, we handed them out during Barcoding NL. That was an event for our collectors. But now you can also request them online on the Arise website. You find a small request form, and there you can request one. It's now only for insects, but then we send it to you by mail, and you also automatically get an account for our online metadata tool, ADA, it's called ADA. And there you can provide us with all the necessary data that we need. So for instance, the identification, if you have that, of the species, and location, collecting date, all that really important information. Yeah, so since October, we handed out 47 of those sampling kits already. And in the entire year, 45 experts provided 2,700 identified specimens for us. So we are quite happy with that. Yeah, so when we receive the specimens, people can just send a sampling kit back to us. We prepare them for the sequencing team. And what we do is we take subsamples if that's necessary. We also take images, and these images, which I found really beautiful, they are taken with our new Keyence camera, and that can take images of individual specimens of an entire plate in 20-25 minutes. It's fully automatic. So we are really happy with that. And we already took 3,500 images in just a few days. And we also take images of one entire plate. So that's sometimes handy also with analysis, that maybe there's contamination between wells, then we can see, oh, what happened there. And that's nice. So yeah, in this year, we almost subsampled 10,000 specimens. And also, if we have any voucher specimens, we store them in the biobank collection. And then everything's ready to go to the sequencing team. Yeah.
Yeah, so the plates with the specimens come into the lab, and there we've been working on fully automizing most of the workflow. So I've already shown this this image before, I think, of our big DNA extraction robot. Just to give you an update on some statistics, so we work in what we call batches. So we collect a number of plates together, usually 24 plates that we work on simultaneously. So we did about 250 plates so far. You can see almost 24,000 DNA extracts have been processed by ARISE. And then, of course, we need to get the DNA barcodes out of that, which we do with a conventional PCR method. And we're almost at 90% average success rate for that. So it's a pretty robust method. We've been working very hard to create our own homemade DNA extraction protocols, and this really shows that we get DNA extracts that are of sufficient quality, high quality, to get actual products out of it. We have been working a lot on the protocols last year, or this year still, and we're now in the process of sort of writing them all up. They're now in what we call ready for the lab stage. As you can see on the next slide, has basically a collection of protocols that are used by the lab. These might not be as easy to read for people that don't work in our lab. So our next step is what we'll do early next year is rewrite these protocols so that we can actually publish them and that other people can start using them in their own respective labs. Other than that, we of course also been working on the pipeline tools that come after the sequencing. And so this is all the lab work, basically using pipettes. But as you can see in the next slide, we've been working also on making the pipelines more accessible. The situation right now is that if you have a data set coming from the nanopore and you want to use it or you want to analyze it on the way that we process them, you need to go to our bioinformatician. Of course, that's not very optimal. And so we've been working lately on making sure that these pipelines are easily accessible in pipeline management software called Galaxy, which will be can be used by basically by anyone, and so it doesn't require any knowledge of scripting or code. Basically, all the options have been put into like nice drop-down menus to make it a little easier to work with this kind of data. Of course, this is only for the first steps right now. So getting the raw data in, getting your clean sequence data out. But then once you have a clean sequence, it's not finished yet because we need to decide, is this sequence a valid sequence? Did we actually sequence the organism that the collector supplied, or did we sequence maybe a bacterial contaminant, or maybe even we sequenced one of the people handling the samples? And so we've been working on setting up this sort of decision diagram on how to decide which sequence is automatically validated and which sequences are automatically discarded, with also some options where we still have to have an actual person look at the sequence data to make a decision. So basically, it looks complicated, but it's quite easy. So first, there's a few steps where we look at is the sequence the correct length? Does it have all the features that we expect from a sequence? And then after that, we match it against what we call the contaminant database. So this is a database that we created with like bacterial sequences, human sequences, other known contaminants that might be there, just to make sure that we can already exclude those sequences from the further analysis. And then after that, we compare to a curated database, so which contains our own sequences, but also public sequences for which we know they are correct, to see if we can get any matches. I always say, hopefully we don't get too many matches, because a lot of the specimens that are brought to ARISE should be specimens where there's no reference sequence available yet. But with some clever tricks, we can still match it to see if the sequence belongs to a particular order or a particular family. And then we take that information plus also the information as supplied by the collector, and then we can see does at least the name that the collector supplied and the name that the DNA pipeline appends to it, do they fall into the same taxonomic group? And so is this beetle sequence actually from a beetle specimen and not from a fly specimen? So this is sort of a work in progress. Hopefully this is also something we at one point can just publish as a tool that people can use. And of course, some of the rules might be a little trickier to script. And you see that there is some human intervention needed every now and then. Just some statistics on the next slide of what we've done so far. So we almost 20,000 barcodes passed the contaminant check. So we know that's barcodes that are not a bacteria or Homo sapiens. These are from around 15,000 samples. So you see that there's still a lot of samples that actually have more than one valid barcode that is not really known as a contaminant. And so in some cases, we've already seen these are parasites. Of course, we cannot add parasites to the contaminant database because in some cases we do actually sequence the parasites. And in some other cases, I've already seen one picture from the Chians where there was 2 legs. So probably someone accidentally put 2 different species in the same well position. So these are the kind of things we need to check manually. So there's still a lot of work to be done. And of those 50,000 samples, there's about 13,000 records where the match between the sample sheet, so what was supplied in the beginning and what came out of the DNA extraction is at least a match on class level. I say class level because we are dealing also with a lot of material that comes from traps, which are not really identified to species level. And so we're really looking at a high level here. Is it at least an insect sequence that comes out of this Malay trap specimen? And then we can store it for further use. All this data, all these sequences will end up in what we call the core sequence cloud. We now finally started working on what we call the day 1 version. So this is really focused on making sure we capture all this nanopore sequence data and link it to metadata from other systems. And so all the specimen data that comes into ADA that's stored in a collection registration system, but also the LIMS that we'll eventually have or a temporary solution in between, so that when we have a sequence, we can also see sort of its history and what happened to all the steps in between collecting the specimen and getting the sequence. And of course, help us with like registering some of this validation.
Yeah. Okay. Yeah, so when we have the results, we of course want to update the target list because we do not want to collect any specimens unnecessarily. So there's actually 2 updates of the target list that we do or want to do. The first one is update of the species names, because of course also changes occur in that, and we base it on the Dutch species register. So when changes occur there, we want to make the target list up to date. And we just did that 2 weeks ago, and we want to do that every 2 months now. And with the last update, we also removed some messy stuff in the data that we found. For instance, species that are not named or incorrectly named, of course, you cannot look for them. So we do not want them in the target list. And then the second one is, of course, the new barcodes. Incorporate them in the target list. We are almost ready for this to do this update first time. Then of course we also want to publish and share these results with the collectors and experts that we work with. So that's the last step. Oh no, sorry, I forgot this one, very important. Yeah, so this is actually the result of the last update of the species names of the target list. So you see for each kingdom that we focus on, 2 bars, one before the update and one after the update. And you see that for every kingdom also the amount of species went down, because of course we deleted some that we didn't want in there. And in the bottom of each bar, you see how many barcodes we have within Arise for that kingdom. There, if you pay attention, you also see that that also went a bit down. And we first thought, oh help, what's that? What happened? But now we know that there's mostly species that are not named. So we have a barcode, but we do not know the name. So it's logical that they are not in the tag list. Yeah, so we asked collectors and experts during barcoding and now how they would prefer to receive the results. And yeah, so a platform, website, online, in combination with email notifications is for us now, I think, a good way to go. For now, when we have the results, we will depend on email, but we are also working on a platform. And our intern Nicolette is also here, I believe. She created a good, very beautiful design for us for our sample dashboard platform. So these are screenshots of the design. It does not exist yet, but this is what we want to build. So on the left, you see a sample dashboard where you can see look into your own projects, projects that are shared with you, or public projects. And yeah, so for now we thought it's handy to have at least the title of a project, the amount of specimens, and a kind of progress bar that you can keep track of your samples. And then the idea is when you click on one of the project's titles or that bar, that you can go to this detailed page that you see on the right. And there you find of all the samples that you handed in, the status, the identification you gave, or the collector gave, and yeah, the ID that we found in the DNA results. So yeah, we are now in a phase of testing this with some of our end users. And yeah, it's maybe nice if you think, hey, I'm really interested in this. I'd also like to test with you. We really appreciate that because we really want to make it user-friendly. And yeah, that's only possible when we have a lot of feedback from the users. So please feel free to contact me or Rise, and we'll look into that. So for next year, we are going to try to have more, of course, we have some priorities for the specimens that we collect, policy, insects, pollinators, but within those groups, we would also like to look for smaller taxonomic groups, because it's nice to have complete sets of DNA reference for an entire group for research. I think it's nice and helpful, but it's also really nice for the team, because you can imagine collecting all the insects of the Netherlands is a huge task, and sometimes it can feel a bit like an endless task, and it's really nice if we can complete smaller groups. So if you can help us with completing that, feel free to, or have any taxonomic group that you are interested in, contact us. But we do want to at least start sampling mushrooms and plants next year, and also do some trap projects to reach higher numbers of specimens.
Yeah, also, of course, a little outlook for next year for the sequencing team. So like I said, part of the work is now automated, but part of the work is not. And so we're still working on integrating some more robotics into the workflow to really make the work a lot easier and quicker. We're also starting with the meta barcoding. I've already mentioned this, I think, in the last town hall, where we set up some meta barcoding pilots. So basically our round 2 for meta barcoding, and to really optimize things like soil processing, also for the upcoming identity project. And then set up some protocols for really working on bulk processing of these malaise traps, so that we are not just sequencing every individual individually, but at one point we can just use the whole trap as an input and then sequence it all together to see if there's actually anything new or interesting in that trap without having to sort it all out. And also some projects that will help us find blind spots in the reference database. So people doing some meta barcoding might end up with a bunch of sequences that they cannot identify, and then hopefully we can sort of pinpoint where these gaps in the reference database still are. We'll continue setting up the sequence database and of course the laboratory information management system, and then also do some work on data validation and publication strategies. And like I said, we'll look into publishing the sort of end-to-end workflow for the insect barcoding. And so not just the lab protocols, but basically the whole workflow as a paper, so that everyone can sort of see how it goes and maybe do it themselves.
All right. So besides identifying species based on DNA, we can also do that using digital sensors in the field and AI pipelines for species identification. So the next part of this town hall will be about the end-to-end pipeline for the Diopsis insect cameras. You've seen these quite a lot in our last presentations, but we can finally show you the whole process from camera all the way to AI species identification. So this process, similar to the DNA identification process, includes several steps. We also need to start with collecting data, not so much by sampling specimens in the field, but by deploying sensors in the field. The data that all these sensors collect are then ingested into the ARISE infrastructure, where we store and manage all that data in the BioCloud. Then the media, as well as all the algorithms that we have available in the AI repository, can be viewed by users and selected to use a specific AI algorithm for species identification, and then view the AI results in the ARISE portal. So yeah, the first part of this end-to-end pipeline is mostly captured by our monitoring demonstration sites team, which is led by Daniel Kissling from the University of Amsterdam. Unfortunately, he couldn't be here today, so I'm taking the honors of presenting some of the work that they did on his behalf. So besides the Diopsis insect cameras, they have been working with a lot of other types of sensors, wildlife cameras, but also sound recorders, radars, and even cameras that take pictures of the sky, where you can kind of connect that to the radar data that it collects. So there's a lot of variety of sensors, a lot of variety of data. Not every sensor collects a huge amount of bytes compared to like astronomical data, but still, if you would monitor species with these kind of sensors throughout the Netherlands, it's a lot of petabytes of data that we are collecting. All right, so ARISE is mostly focused on building an infrastructure to facilitate research rather than doing the research ourselves. But of course, we do want to understand how the research community will use the infrastructure and what kind of questions they are trying to answer. So the MDS team is placing the Diopsis cameras in locations and focuses on these two main questions. So they want to look at how grazing by large herbivores influences the insect biomass and the community composition. So they do this by placing the cameras inside and outside of grazing exclosures. And on the other side, they want to look at what kind of insects, both abundance and diversity, you can detect with these cameras. So they do this by setting up the cameras in different positions, like you can put the screen horizontal or vertical, but also to compare it to other methods of monitoring insects, such as malaise traps. So so far they've been putting the Diopsis cameras out at 3 of their main monitoring demonstration sites. So one is the Amsterdamse waterleidingduinen, where the cameras have been placed also in the vicinity of the Malaise trap, so they can do that comparison between those two methods, similar to the Oostvaardersplassen. The image in the bottom right corner there, you actually see a Malaise trap next to Diopsis insect camera. So the Malaise trap results will go to the sequencing team to analyze all the DNA barcodes, and then we can compare that to the results from the Diopsis camera. And the third site that they have is the Artis Zoo in Amsterdam, where they have really good access to facilities such as Wi-Fi and electricity, and also show the public what we're actually trying to do with these sensors, as it's pretty new technology to monitor biodiversity. So for Diopsis, all the images that are collected are actually first sent to a server of the company that develops the camera, so that's Faunabit. That doesn't really apply for all sensors that we can use for biodiversity monitoring. So for other sensors, the ingestion will probably go straight to Arise. But we take the images from the Faunabit system and ingest that then to BioCloud. So from a BioCloud perspective, this is where all the data needs to be stored and managed and handled. In this case, we pull all the data from Faunabit into what we call our data landing zone, and then we can start processing this data. I've shown you the concept of a data lakehouse architecture before, which might be a bit abstract for some of the ecologists in the field, but I'm going to try to do my best again to explain this. So the first step, the images all go to one side. We put that in a what we call a blob storage, and the metadata is really where most of the work comes into how we store and manage that data. So we get the metadata from each of the data sources, in this case Faunabit, into what we call a raw format. What you see here is JSON files with information about locations, about the sensors, about the images, about deployments, so where was a sensor placed and when. And we just ingest all the information that a data source can provide to us in our raw layer. What we then do is actually I would say that the core really of the BioCloud. So in the enriched layer, we need to somehow transform the data that we get from a data source to our own system. So you can't really see the details here, but on the left in that yellow surrounded box is the data model from a data source. They have a table that's called location researches, which matches to what we call deployments. So this is where was a sensor placed from which time and at which location. So we need to map all the information that we get from a data source to our own Arise data model. And why is this important? We don't just want to do this for Diopsis, but in the very near future, we're going to connect a lot of other data sources, data coming from wildlife cameras, from sound recorders, from radar, and they all have a table, for example, called locations. So we have locations from Diopsis insect cameras, we have locations from MDS wildlife cameras, we have locations from sound recorders. And if you want to look up in the Arise platform to be, give me all the information about the Amsterdamse waterleidingduinen, not just from a Diopsis camera, but any species that have been found there. We need to harmonize the different location tables from all the different data sources to our location table in the Arise BioCloud. So this all happens in the enrichment process. And we don't do that just for location tables, but also for the sensor tables, the deployment tables, all the other tables that the data sources provide us. And this is what then a table looks like in the BioCloud. It's just a list of all the locations. We give them a golden ID. That's a unique identifier within the BioCloud so that we can link all the information from one particular location to each other. And then the last step in this whole processing flow is the curated layer. That's actually just a filter for whatever system wants to use the data in the BioCloud. So at the moment, we have a filter for the Arise DSI portal that Jacob will show you in a bit. So the curated layer is really a specified view for the target system that's going to use the data. And at the same time, while they read the metadata from our curated layer, it also provides the link to where the actual media file that is linked to particular metadata is stored in the blob storage. So they read the metadata from our curated layer and then can access the media file immediately from our blob storage. I think that was me, so I'm handing over to Jacob now, who will explain a bit more about what happens once we have all that media in Arise.
Yeah, thanks, Chantal. So my name is Jacob Kamminga. I work at the University of Twente, and I'm the team lead for the DSI team, which, as most of you will know, stands for Digital Species Identification. So Chantal nicely showed you all the guts of the machine. The DSI portal is actually what you'll most likely see as an end user. So, for example, if you own the Diopsis cameras, this is where you will see your images show up. Now we have to start making sense of all that data, right? So some of us actually use multiple sensors. So what you'll see today is actually a mix of data from wildlife cameras and Diopsis cameras. So how do you actually organize all this? The way we currently do this is by using filters. We call this a dynamic filter. We call these dynamic filters because you can actually mix and match to start using them for your data. And I'll show you some of them right now. So if you currently log into the media browser, you'll actually see 1.6 million media items. The images here are wildlife camera images, but we're actually talking about Diopsis. So what I can then do is add a first filter, which is a sensor filter. If we go to the next slide. So I can filter for Diopsis camera 211, which now shows me 205,000 media items. I may want to actually narrow it down to a year, so I can add another date filter. So I want to only show images from 2021. But of course, we can go more detailed. So for example, if I want to only look at 2 months, I can actually start adding different ranges. Well, I guess this speaks for itself. Now you see a range of black items. So this means something went wrong. And in the real world, many things go wrong. So in this case, probably a camera where the light wasn't turned on. And so it took black images at night. So you may want to discard these images, right? Traditionally, people may just delete them or put them in a folder. But our goal is to actually use this system to organize your data by using labels, for example. So if we go to the next, what you see here is a screen of our first label management page. You can actually create new labels with descriptions, even give them a color. And this you can use to organize your data. So you see there's a label for black image. So if you go to the next screen, if I find something that I want to filter or organize, I can use shift click to select a large range of images and actually select a label. In this case, I will add a black image and add the label to these images. So if you go to the next screen, now you see black dots on the black images, maybe not the right color, but it's a way of quickly adding tags to your items. But now we can actually use this information in our filter. So if you go to the next screen, you now see that I added another filter, which is exclude certain labels, and I selected black image, which means I'm now looking at the same images, but not the black images. So this is a process of adding filters to organize my data. If I go to the next slide, if at some point I'm happy with what I'm looking at, I can actually define a data set. So I click a button, create data set. I can give this set a name, and it will store these filters and of course the media items as a data set. Now we can use this data set to start using AI. So this is an overview of the current algorithms in production. And one of them is the Diopsis inference server, but also an algorithm called megadetector. Now, megadetector I'm going to use it as an example in the next slides. Mega detector is a generic algorithm used for wildlife camera images to detect animals, cars, or humans. And of course, we have Diopsis. So if I would want to use the Diopsis algorithm to analyze my data set that I just defined, I simply need to select the algorithm, the data set. I can give the job a unique name. And when I click Start Analysis, the whole process of running the algorithm is automated, and it's sent to the Dutch supercomputer. You have to wait a while, and then it will return the results for you. Now I will run this twice. So I will start one with Diopsis, but I'll also start one with the mega detector algorithm. And all it takes is 2 clicks. Now first, let's have a look at the results. So the analysis has been run. What you see here is actually one image in the data set of insects. And it's actually not analyzed by Diopsis, but by mega detector. So all it shows you are these detections and that they're probably animals. Go to the next slide. This is more zoomed in. On the right side, you see algorithm results. So this is a view in the media browser when you click on the image. And then on the right side, you actually see all the algorithms that have been run for this particular image. You also see checkboxes. So if I go to the next slide, we switch from mega detector to Diopsis. And there you see that the Diopsis algorithm actually has more details about what it saw on those images. So this is a nice first step in comparing the actual analysis output on media items. Of course, you can also download the results on the next slide. So for a whole analysis job, which can comprise millions of images, you can actually download the output in the form of JSON or CSV and import this into your favorite data analysis tool for further research. But now it gets interesting, right? Because now we have run the AI, we have some analysis results. So can I actually use the output of algorithms to organize my data? So there's a feedback loop. And yes, we can. So for example, if I have media items, many cameras, wildlife cameras, but also Diopsis, they often record empty images. So if I just start browsing millions of images, a lot of the stuff is empty. So one straightforward filter we have is only show me images where an algorithm detected more than X items. So here you see images that have more than 15 detections in them. And this is a nice way to narrow down to interesting data. But more interesting is the next step. Can I actually now start looking for species that have been detected inside my data? This is currently working for mega detector, as soon also for Diopsis. But mega detector can look for persons, for example. So what I'm showing you here is the output of mega detector, and I'm filtering for persons. So these are not human added labels, but these are detections by the algorithm. And I hope you now have an idea of how we can actually combine human tags, but also algorithm output to organize our data. This is where we are now. We have also tested this with actual users of Diopsis. We had 2 users test sessions at Naturalis, and this image is at Radboud in Nijmegen. And we got a lot of interesting feedback that we are currently incorporating or have incorporated. So the system is live, it's usable, and we are now getting into the process of people actually using it. So that's awesome news. Outlook, we have achieved a lot, but there's plenty to do. Next year, we are going to launch our very first AI Biodiversity Challenge, where we will invite different student teams from different universities to compete and actually propose new algorithms. And we'll start with Diopsis. So we will share the Diopsis training data and invite students to submit new algorithms and also compare them with each other and make it into a nice competition. We are also, we have started with integrating with annotation tools. So if you're an expert and you see new interesting data that you want to annotate, we will make it very easy for you to do so. We are streamlining the process of adding algorithms. We are currently adding many in parallel, and we are learning how to improve this. So next year we'll make this even more easy to add more algorithms. We are also going to demonstrate automated training. So if you do supply new annotations, that means you are creating new training data. So we can actually use this data on the fly to improve the algorithm you are using. That's our goal. So that you also notice over time that the algorithms get better and better. And we are adding more algorithms on the next page to give you a glimpse of what's currently happening. We are almost finished with adding a geese counter for wildlife cameras to count geese, or flocks of geese. The Naturalis bird sound classifier is almost ready, which means you can process audio to detect bird song. There was a Capgemini challenge, which is a commercial company, and the winning team is now working on adding the cricket and cicada sound classifier into our system. If the challenge is a success and we have some nice algorithms that actually work, we will also make them available to use on actual Diopsis data. We will work on a model or integrate other models for Dutch species and wildlife cameras. We're also working on prey detection, avian nest boxes, and we are working together with Fontis on flower power, which has the goal of detecting flower biodiversity using drone footage, and many more to come. Just to give you an idea of all the algorithms that are being added or will be added. And this was my my outlook. And I'll hand back to Chantal to give an outlook for the monitoring sites and the BioClouds.
Yes, thanks, Jacob. So MDS will do way more than just looking at the outcomes of the Diopsis cameras, but this is what they're planning to do with all the data that the Diopsis cameras have been collecting over the last 2 years. So really look at the difference inside and outside of the grazing exclosures based on the identification on the images. Look at the difference between the vertical and horizontal screens. We have already seen from some pilots that especially on a horizontal screen, daytime flying insects like to land. So we definitely see some differences there, and that will have implications for how ecologists in general might want to use these cameras, as well as looking at the differences with the traditional monitoring methods. As for the BioCloud team, we're really happy that we finally have a real working end-to-end core system to do all the harmonization of data. It's still mostly working in a test environment. So one of our first goals of 2024 is moving to a stable production environment. We have already started on the pipelines for the wildlife cameras, all the data that comes from the MDS camera. So that will be implemented also in this end-to-end pipeline. We're also working pretty hard on getting authorization in place so that we can give people access to the platform, but in a way that they can only see their own data or data that is shared, rather than immediately opening up everything for everyone. We started work on a service layer, so an API for data access and export to other systems. We have a test set up for the implementation of persistent identifiers, and we'll put that to further work in 2024. And we also really want to ingest all the results from the DSI team into BioCloud, because that means that the DSI results are also used as a data source. It means that we can actually use that data for the species reference database and link that to data from other sources, and have all the species information of images and sounds ready for the species reference database. So plenty of work to do, but we are pretty confident that we now have kind of the system stable enough to start really working on this. Other than that, we also have already given Arise a bit of a face with a first version of the platform and the target list, but we do now have a UI UX person on board who will work in 2024 on really on the Arise platform and giving people more access to services and data. So this is very exciting. Plenty to come in the new year. I'll hand back to Elaine for, I think, some final words.
Okay, that was a smooth transfer. And well, I hope you all share my feeling here that 2023 has been an amazing year. A lot of things have been achieved, from big machines like the Kians to robots in the lab to digital tools to help out the streamlining of the process from field to lab to actual data. And also on the digital side, right? Having 8 different types of sensors in the field, capturing that data. Of course, we cannot process everything yet. We cannot answer all questions yet. Also, to all of those experts that have been providing samples, please, 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 a little bit more patience while you wait for your results. We're really getting to a place where we can share that information in a much better way than just emailing you back with a FASTA file of your DNA code. The real goal is connecting that data, and we're getting really close while we're entering 2024. So 2024 will be hopefully amazing. Arise Day is hopefully marked in your agendas. This is the place where we'll give our next town hall update, but also provide good workshops where you can actually touch the data and really interact with Arise, so that you can also help us provide useful feedback. Is this useful, right? We can think about what's useful, but we need to hear this from you. Stay up to date, stick around. I'm gonna close the recording here, but please stay around for a lively discussion online for today.